Good afternoon, students. We're going to be picking up in our notes talking about the gas laws. This is still in Chapter 11, and it's going to be Chapter 11, Part 2, on behaviors of gases. So there are going to be a number of gas laws we're going to learn. We talked about pressure last time, and today in class we're talking about pressure, volume, temperature, and proportionality, so directly proportional or inversely proportional. Two laws we're going to get today. The first is called Boyles Law, and that is the pressure and volume relationship. That's what the law deals with, pressure and volume. So the volume of a fixed amount of gas varies inversely with the pressure at constant temperature. Now the word inversely, that means that as one of these goes up, the other will go down. So as pressure increases, volume will decrease. So they're opposite. One goes up, one goes down. And we talk about that in class today. If you double the pressure, then you'll be cutting the volume in half. Vice versa, if you double the volume, means the pressure is cut in half. And here's our equation. P1 times V1 equals P2 times V2. P stands for pressure, V stands for volume, P2 is pressure 2, V2 is volume 2. Okay, so it's kind of a before and after thing. So here's an example problem that we're going to do together. It says a sample of oxygen gas has a volume of 150 milliliters when its pressure is 0.947 atmospheres. Now atmospheres, ATM, is just a unit of pressure. And what will the volume of, so here's what we're looking for, the volume of gas be at a pressure of 0.987 atmospheres, ATM, if the temperature remains constant. Okay, so temperature is not going to be in this equation. We're going to use our P1 times V1 equals P2 times V2. So this means the pressure and volume we start with, the pressure and volume we end with. So I'm going to go through and find my variables. So a sample of oxygen gas has a volume of 150 milliliters. I'm going to call this V1. Okay, it's the first one in the equation, so I'm going to call it 1. It says it's a volume of 150 milliliters when its pressure, so here's the pressure that goes along with it. So that's going to be P1. Okay, so P1 is 0.947 atmospheres. What will the volume, so we're looking for V2, the other volume of the gas be, is the pressure of 0.987 atmospheres. Okay, so this is that pressure. Next, P2, if the volume remains constant, or the temperature remains constant. So we're increasing the pressure. We're going from 0.947 to 0.987. Okay. So let's think about this before we calculate. If this pressure is going up, we said that pressure and volume are inversely related. So if the pressure goes up, that means if pressure is going up, that means that volume is going to be going down. Okay, so our number that we get for V2 should be smaller than 150. So let's take our equation. P1 times V1 equals P2 times V2. All right, and we want to solve for V2. So we want to get it by itself on one side of the equation. So if we're multiplying P2 by V2, we can get rid of P2 by dividing both sides by P2. So we're rearranging our equation. So P2's will cancel, and the equation we're going to need, so V2 is going to be equal to P1 times V1 over P2. All right, so let's go through and plug in our numbers. P1, we said, was 0.947 atmospheres. It is important that you always have your units, okay? That has not changed. Okay, V1 is 150 milliliters. Okay, and then it's going to be over P2, so 0.987 atmospheres. And the reason the units are important, because we're comparing these pressures, atmospheres are going to cancel and we'll be left in milliliters for our goal. So we calculate 0.947 times 150 divided by 0.987 gets us, I'm going to round to the nearest whole number, 144 milliliters for our final volume. for V2. Now, does that make sense? We said our pressure is increasing, so our volume had to decrease. So it should have been less than 150, and sure enough, it was. Okay, so you're going to be getting good at rearranging these equations and solving them. All right, so let's keep going. We have a few more practice problems, and let's see here. Let's try this one instead. Oop, let me go back one. All right. So that one, if you want to take a second and try it, there's the answer you should get. So you can try that on your own. I'm going to do two together instead because it's a little bit different. So it says a gas has a pressure of 1.26 atmospheres and occupies a volume of 7.4 liters. If the gas is compressed to a volume of 4.93 liters, what is the pressure? So let me get my pointer here. So let's go through and figure out what we know. We know it's going to be Boyles Law here. So a gas has a pressure. So here's the first pressure, P1, first one in the equation, and occupies a volume, so first volume. So these guys go together, P1, V1. If the gas is compressed to a new volume, right, a new volume, so it's going to be V2 of 2.93 liters, what's the pressure? So we're looking for P2. Okay, we're going to get P2 by itself. So we're assuming temperature doesn't change. Let's think about this then. Our original volume is 7.4 liters. And if we compress that, that's almost down to half. What's going to happen to the pressure? Okay, if we lower this number, because they're inversely related, that means the pressure should go up. So our number, whatever we solve for P2, should be greater than 1.6. So let's write our equation. P1 V1 equals P2 V2. And we want to solve for P2. So I want P2 by itself. I can do the same thing as we did the last problem. I'll get V2 out of there by dividing. So then our equation ends up being P2 equals P1 times V1 over V2. So let's put our numbers in. P1, 1.26 atmospheres. V1, 7.40 liters divided by V2, which is 0.93 liters. Okay, this time our liters are going to cancel. We left in atmospheres for a unit. So if we calculate, we take 1.26 times 7.4 divided by 2.93, and I get 3.18 atmospheres. Okay, so there's our answer. Okay, so again, it is much greater than the original pressure because if the volume decreases, the pressure is going to increase. All right, so I'm pretty confident in my number. And there's my answer. Yeah, I had it there. All right, so let's keep going and we'll talk about one more law. All right, the last law for today is called Charles' Law. So it's actually, it's not just Charles, it's Charles. I think he's French. So you hear me say Charles' Law, it's because he's actually, that's how you pronounce his name. But this deals with volume and temperature, and you're going to look at that today in lab. The volume of a fixed mass of gas is directly proportional to its Kelvin temperature if the pressure is held constant. So if you remember, we talked about this today, directly proportional means as one goes up, so does the other. Okay, so if the temperature increases, increased temperature, the volume will also increase. If you decrease temperature, the volume will also decrease. So they're directly proportional, directly related. Here's the equation, V1 over T1 gives us V2 over T2. And here's the units that we use, milliliters or liters for volume and Kelvin for temperature. It has to be with a Kelvin temperature. And that's what we're going to stop there today. We're not going to do any practice problems with these. All right, thanks folks, and we'll see you in class.